Hey everybody, this is Larry. This is me over Q4 of the weekly contest 287. Distribute elements into two arrays 2. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about this one. To be honest, this one really only has one tricky part, if you will, and that's how I was able to solve it in like 4.5 minutes. Even though I had a typo, so I had to fix it. So yeah, but the idea here is just like how to implement this greater count. And there are a couple of ways you can do it. I'll talk about a couple of them. I'll show you mine first, and this is a very Pythonic solution. So if you don't use Python, we'll talk about other things for sure. But basically, I just use the thing sorted list, and in sorted list, you just have a list that's sorted basically, and every operation is roughly speaking log n. I know there's some caveats, but you can pretend it is log n, and yeah. And basically, I also maintain this list, so then now I know where to go. I do a binary search. That's mainly the function on the sorted list. And this gives me the count of how many numbers that are greater than on the first one, numbers on the second one. And then, I just do all the if statements that they tell you to either add it to first or second. And that's pretty much it. And then you can cat it. Like I said, the hardest part is just like knowing the data structure to come up with. And yeah, and that's to support the operation of this greater count, right? So I gave you this one with sorted list. This is really Pythonic. In C++, I would actually also recommend so there's maybe like order statistics tree. You could also maybe, if you have an implementation of tree, or if you want to implement it from scratch, you can maybe do that. You can also normalize the numbers, normalize input, and then use binary index tree or sigtree. I don't know if sigtree is too slow for this one, but in theory, like the constant may be too high, but in theory it'll also be n log n and stuff like this. So you could use this, and yeah. And I'm not gonna go over this one or this one. You can Google this. The normalize I'll go over a little bit, but basically the idea is that the input can go up to 10 to the 9. If you re-index every number because only the relative position matters, then you can re-index them or compress the coordinates is another way of putting it, from 1 to 10 to the 5th. And then there you can use binary index tree or a segment tree to do the query of how many numbers are between x plus 1 and infinity, right? Or something like this. So that's basically the idea, using prefix sum ideas, right? And that's pretty much it. All of these should be n log n on average. There's some probability in some of them. There's some weird, things for some of them, but that's basically the idea. Honestly, should be pretty okay, but it is just like a quick library check of like, hey, do you know your libraries, or do you have this implemented? I don't know. It is what it is. I don't find it that interesting. Is it an interview question? I don't know, because the thing is that like all of these inputs are kind of annoying for a live interview, even sorted lists, to be honest, because a lot of places don't have sorted lists. If I were on an interview, I may just talk about a balanced binary tree. Maybe balanced binary tree. With something with a rank on the nodes, so that you also keep track of balancing, like in theory, like web black tree or something like this. But I don't know. I don't know how to do it, to be honest, right? I don't know how to implement that from scratch. So I don't know. But in theory, that's how you could do it. But yeah, that's what I have for this one. Mine is n log n because these are log n operations. The addition is also log n operation. And this is just an additional of n at the end. And of course, this is linear space because we just have 4 linear things and 1 more at the bottom, maybe. But yeah, that's what I have for this one. Let me know what you think. And yeah, you could watch me solve it live during the virtual contest now. 3 and 12. All right, let's go. No typo, please. Okay, thank you. Let's take a look at the leaderboard real quick just to kind of get a gauge. All right, it doesn't load. Thank you for your virtual contest. You are useless. All right, I mean, we know what this problem is, right? Maybe. Oh wait, is it? Is it the same one or not? No, it's different. All right, so let's take a look. N is big, So okay. What we define the number of arrays that are strictly greater than y. All right, you need to distribute all the elements of numbers. This seems straightforward, right? It's just like a binary search, right? So yeah, all right. Oh, but you have to return the. No, that's still fine. It's just binary search. You just keep track of two things, right? So yeah. And basically, so this one. I guess I should have done this contest. It seems pretty straightforward so far. I mean, maybe I'll make a mistake here and make me, regret what I said, but I think, I don't know, right? So for I in range of, or maybe even just like for x and something like this, right? So then, okay. Let's double check that. Okay, greater count, okay. Yeah, okay. So G1 is just equal to SL1 dot, what's it called? Bisect strictly greater than, right? So bisect right of x, and then G2 is equal to SL2 dot bisect right of x, and then if G1 is greater than G2, then yeah, A1 dot append x, SL1 dot add x, else if G1 is less than G2, then A2, right? Something like this. Watch, I misunderstood this problem. If they tie lesser elements of, okay, so else if, I mean, this should be true. Okay, fine. Else, if G1 or length of A1 is less than length of A2, what do we do again? Fewer? Okay, then we want to, maybe I should have a helper for this one. And then just A1, right? Definitely should have a. And then what do we do? And then we still just do like same length, right? Am I misunderstanding this problem? 2, 3, 3. Oh, I got something wrong. Okay, maybe let's take a look. 2, 1. The number of elements. All right. Let's just take a look. Huh? How did I get this wrong? 2, 3. Okay. And then 1, 3. Oh, why did the number of elements greater than 3 is 0. Did I mess this up? Oh, greater than. Oh, I messed this up. I mean, that's fine. It's just changing the binary search. It's just changing this thing. So greater than is just going to be right? I mean, that's pretty much it, right? I mean, 2, 3, 1, 3, 5, 3, 1, 2, 14, 3, 3, I mean 3, 3, okay, fine. Alright, no typo, please. Alright, this was a silly contest, I think. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this virtual contest, this problem, everything in between, this explanation. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.